In this video, our goal is to see if we can use PICmicro specifically to put a put output out there and accept input. And more specifically, we are really focused on using this divide as a digital I/O, input and output. Okay. So one of the first things we got to do is figure out how many of these things do we have. Theoretically speaking, we have 8-bit or 8 pins to support port A. Okay, and then we theoretically have 8 bits or pins to support port B. So if that's all we want to do, then theoretically we can use these. We have access to 16 inputs, output, digital inputs and output that we can work with. But before we get carried away and decide that's really the case, let me point out a couple of things we got to pay special attention to. As you remember from earlier on, this pin actually gives us the ground for the whole circuitry, and this pin, the pin 14, gives us the power, VCC or VDD as they call it here. So we have power. We got the power coming here somewhere between 2 to 5.5 volts, and then 0 or ground is coming in here. So that takes care of those two. So that leaves it. There's 18 pin, 8 pins. I'm sorry, 2 pins are for power and ground. 8 pins are for I/O. There's no more pin left. Well, we got a couple other issues to really think about. This port, which is port 5, bit 5 of port A. That's how they refer to it. RA5 is referred to as the pin 5, port A bit 5. Now the only thing is, it's also the reset. Master clear is the reset. It is really important, although you can use this only as input. You can't use it as an output. It cannot ever be an output, but you can use it as an input if you want, but then you have to give up or disable the master clear. Not a recommended thing. Our recommendation is that we use this pin always as a pull-up to 5 volts, and that this would be a reset signal, a push button or something that we can go use to reset it. Okay, so all of a sudden then we don't have port A, RA5, which is pin bit 5 of port A, is really no longer available. So we are down to, from 16 I/O ports, we are down to 15. That's reasonable. You could do that, assuming you don't want to use this device for anything else. So that's fine. The other thing we start to notice that every time there is, remember RA refers to port A bit, so when bit 0 of RA also have associated with it a AN0. So RA0 is the digital side. So this pin, this designation is the digital I/O. You can also use this pin if you want to read an analog and know what actual voltage you're receiving. That's the analog. Okay. Oh, so there is another question we need to do. It would look like that RA0 through roughly RA6, yeah, RA0 to RA6 could be used for other purposes such as the analog. Okay, AN0, AN1, AN2, AN3, 4, 5, and etc. So we need to make sure if we want to use it all for digital, we have to tell the world we want to use it for digital. So remember that. So for the the pin bit 5 of port A can only be used for master clear. If you want to disable master clear, which is not recommended, you could use it, and then the other thing we have to remember is a number of these bits are shared between analog and digital, so if you're going to use it for digital, you won't have the analog side either. So for now, we're not going to worry about analog, but we need to tell the processor what we are doing. So now the question is, how do we configure the processor to know that what we are doing? So for example, the issue of whether we are using the analog or digital really gets down to going to these special function registers and setting the right thing. In this particular case, we know this register is useful to force us to be digital or analog. So that's one to remember. The other things to remember, each one of these pins that are capable can be both input and can be output. So somewhere we have to tell the processor whether these pins are inputs or outputs. These guys, these are called tri-state or tris A and tris B. If every bit that is 0, for example, if bit 0 is set to 0, that says that pin is an output. Okay? So if you set a bit to 0, its corresponding bit in port A or port B. For example, if you're using tris A and you set bit 1 to 0, that means that port A bit 1 is going to be output. Okay? And then if you set it to 1, then it's going to be input. And someone told me 0 looks like an O, so that's how you remember the correlation. 1 look like I, so you can remember the correlation. So every bit, there's a correspondence, and then we're going to get to doing some example. Latch is kind of an interesting thing. If you want to know what you wrote exactly as you wrote it out, you can, instead of reading these registered port A and port B, this tells you exactly what is on those pins coming out, okay? Which we talked about, like for example, port A bit 0 is gonna tell me what is on. So let me write this so it's a little easier. For port A bit 0 is gonna tell me what is coming out on RA0, and oops, I jumped around. So, all right, we're back. So it will tell me what RA0 is. So if I kind of look at this thing, that's pin 1. So what it's going to do is going to tell whatever. So let's say I set tris A to 0, so it's an output. Then whatever I wrote to port A is going to show up on here. Okay, and then lat A and lat B will tell me kind of there's a latch inside if I want to read what I wrote as opposed to what really is happening on port A and port B. Then I can read the latch A, latch B, lat A, lat B. We don't use that too much in our conversation. We're going to focus on port A, which allows us to writing out and reading information from the pin, allows us to set the direction, and then this will tell us what's analog and what's digital. Okay. So that's pretty much it. These are the special function registers. We've referred to them a number of times so far in previous videos, so I won't go too much detail, but now we're actually getting to use, we use some of them, but now we get to use all of the ones listed in here. Let's get a little more specific. So, and focus on, for example, port A. So let's see what are the things I need to know in order for me to run port A. Okay. So port A, let's make it a little bit bigger. So port A basically tells me that there is a register. This is a SFR register, port A, and it's got 8 bits in it, bit 0 through bit 7. And then this bit 0 is connected to basically what was the pin that was labeled RA0, pin 1, pin 2, pin 6, pin 7, pin 3, pin 4, pin 15. These are the actual pins on the processor. That would be RA0, that would be RA7. Okay, so now we remember these pins can be input into the processor or could be output. Now the question is who sets the direction, and we know that in this particular tris A sets the direction. So if I come and set this bit, corresponding bit for tris A, so let's go down here, and so if I come here and set bit 0 of tris A to a 1, what does happen? That would make this pin an input. If I set bit 1 to 0, that makes it an output. Another 0 output. And you can see I can change my mind and do different one for almost every one of these. So I can go whatever order I want. Each pin is independent. If you set the corresponding pin in tris A to a 1, it's going to be an input. If you set it to 0, it's going to be an output. And that's all there is to it. The only other thing is before you can do this, you have to make sure that in this ATCON1, and this works, you are forcing basically that to be a digital. In order to force it to be a digital, you have to set all of these bits to 1. This bit, we don't care whether you set it to 0 or 1. So typically what we'll do is the very first thing before we do anything else, we'll make sure that if you're going to do digital stuff, we're going to write this thing, we're going to push is hex 7F, which is correspond to what I wrote in here. We're going to set ATCON1 to this value. ATCON stands for A to D configuration 1. Okay. All right. So now we kind of have a sense of what's going on. Port A reflects, if you're reading, reflects what's on the pin. If you're writing, it takes whatever we write in there and pushes it out the pin. LAT is just keeps track of what we did last. It's not very useful for the type of things we're going to do here. And tris A will set the direction of which way the pin is flowing. Is it input or output? ATCON1 just determine if the pin is a AN0, AN1, RN1, is it digital or is it analog? Okay. Having said that, let's go ahead and just do a little example. Let's say our example, they're asking us to set port A, okay, so that let's say RA0 through RA2 are input, and RA6 and 7 are output. Okay, so in this case they didn't tell us what to do with RA3, 4, and 5. My recommendation is to make it an input. This way you never would have a conflict between two pins, okay? So the way we will do that, first thing we need to do is we need to make sure that is all digital. So what we're going to do, we're going to do a move LW0x7F. And then we're going to do a move F, so, oops, sorry, move WF, we're going to move W to F, then we're going to move it in ATCON 1. So what did we do? We basically made everything digital. And then, this is a good habit to do that. Is not absolutely necessary, but before you do anything, it's kind of a good idea to clear F, the port you're going to mess with. So let's clear off port 0. Oh, I'm sorry, there's no port 0, port A. And now we want RA2 to be an input, which means bit 0, bit 1, bit 2 of the tris have to be 1. 5, 3, 4, 5 we don't care about, so as a cleanliness we're going to set to a 1, and 6 and 7 we want 0. So basically these two indicates that 6 and 7 are output and everything else is an input. Okay, so we're going to just, for simplicity, we're going to turn it into a hex, and this is going to be 3F hex. So what we're going to do, we're going to do a move move LW 0x3F, and we're going to move this, move WF to TRIS A. Now we've set the direction. The next time we write anything to port B, it's going to basically, these 2 bits going to go out, and whatever is on those pins come back in. Doesn't matter if you've set something, if you've set port A to input, doesn't matter what you write in there, it's just going to ignore it. The only thing that's going to go out, everything here is going to reflect exactly what's happening on those corresponding pins. What you write into these 2 pins, yes, they're going to make it out, and it's going to show up on the pins. All right, so that takes care of port A. Port B is very similar to that. As a matter of fact, the first thing you got to do move, before you do anything else, you got to just make sure everything is set to digital pins. So what we need to do is that, and then we need to say move WF into add con 1. This one will make sure everything is set to digital, and then we'll come back around and say, okay, let's say somebody asks us to set half of the pins, the lower half of the byte, the first 4 pins to input, the higher one to output. So what do? So in order the bits to be input, they have to have 1 in the trish, and in order to be output, they have to have a 0, right? So all I have to do is do a move LW0x0F, and then I will do a move WF to trish B this time, because I'm working on port B. Okay? Oops. All right. So that's great. So now I have this thing set up. So this pin, this is an output. I'm sorry, this is an input, 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 output, 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 output. Perfect. Now, what else do I need to do? Well, that's pretty much it. You're ready to use. Let's say, again, it's probably a good idea before you configure all this thing to clear everything, to clear port B at least. So do a clear F, maybe somewhere in here, do a clear F port B, just so we start as a good place. And then that's it. And then remember that whatever you write on port B is going to be pushed on those pins. So on the higher bytes, so pin 10, pin 11, pin 12, and pin 13, and whatever you have on pin 8 through pin 18 will show up RA, RB0, RB1, RB2, and RB3. You don't have to worry that you're going to affect the input pin by writing to port B. It will not do that. The only caution I would give you, there is a certain amount of time that when you're writing to port A or port B, those port A and port B may become deactivated. If they're a short time and infrequent, the pin will never have time to react to it. But if you're constantly on a pin writing to it, you may not see any output coming outside on the pins. So that's so you want to be selective about how frequently you write to those pins. That brings us to the end of this segment, which was basically introducing you to, once again, the configuration, starting by saying there is at least 16 pins of I/O, then putting some limitations on that, introducing the special function registers things, and then giving us a step-by-step process if you want to make use of port A or port B. First, in a digital I/O format, first we got to say it is digital I/O by putting 7F in at COM1, and then as a cleanliness, clear the port before you get started, and then figure out which one is the input, which one is the output. Make sure trish A and trish B correspondingly are set to do it, and at that point, all the information from the pin, whether the input or output, will be connected to the appropriate pin of the ports.